One of the things we need to talk about in this section is the difference quotient, which can seem a little complicated, but it's really based on a really simple idea that you should be familiar with, and that's the slope. So in particular, we're finding the slope of a secant line. Now a secant line is just a line that connects any 2 points on a given function. So I'm going to draw in, I'm just picking 2 random points here. If I draw the line through those 2 points, that's a secant line. Now you could pick any 2 points on the graph of your function and draw a line connecting those 2 points, and that would be a secant line. So let's pick 2 particular points on our function. So by the way, our function is f of x equals x squared minus 2x minus 3. So the 2 points I'm picking, this is going to be the point 0, negative 3. So we get 0, negative 3. And we've got the point 3, 0. So I chose those just because it's going to be pretty easy to calculate. And we can draw a secant line through there. So if you want to find the slope of the secant line, so through those 2 points, so through the point 0, negative 3, and 3, 0, how would you find the slope? So we've got a slope formula that basically says the slope, I'm going to use a secant as a subscript. So the slope of the secant line is going to be equal to, right, this is how you learned it, y2 minus y1, the difference in the y coordinates, over x2 minus x1, the difference in the x coordinates. So for this particular graph, for this particular secant line, our slope is going to be 0 minus negative 3 over 3 minus 0. So the slope of our secant line for this particular section is 1. Now the slope of a secant line tells us the average rate of change over that interval. So in other words, over the interval from 0, as x goes from 0 to 3, the function is increasing on average 1 unit for every unit of x. So 1 unit of y for every unit of x, it's increasing. That's the average rate of change over that interval. Now, average rate of change, if you look at what's happening, if you start over here where your function starts here, right, it's actually decreasing on the first part of the function, gets down to the vertex, and then it starts increasing. But on average, right, since it ends up a little higher than it was before, your function on average is increasing. Okay, so that's for a specific, the slope of the secant line for a specific point. For the difference quotient, we're going to do the same thing, except we're going to generalize it. So for the difference quotient, here's the same function. I'm going to pick a couple of points. I'll use green this time. And I'm just going to pick a couple of random points. I'm going to pick this point here, and I'm going to pick another point. Let's call it here. And so for this point, I'm going to erase this negative 2. I'm going to say the x value for this point, I'm just going to call it x. And the x value for this point over here is going to be some number h units away from x. I'm just going to call it x plus h. So the notation is really the trickiest part of this. I'm going to erase part of this function. I'm going to leave that part. The notation is, in a sense, the trickiest part of this. So if you look at this point here, the x-coordinate is x plus h, and the y-coordinate is the value of the function when x equals h. So the y-coordinate, you can write that as f of x plus h. So that's that. Over here, that's the trickier one actually. Over here, this is a little easier, right? The x-coordinate is just x, and the y-coordinate is the value of the function when you evaluate it at x, which is just f of x. So if you try to find the slope of the secant line in this generalized formula, it's going to be the difference in the y values, right? So it's going to be f of x plus h minus f of x, right? So that's the difference in your y values all over the difference in your x values. So the difference in your x values is x plus h minus x. Now you can simplify that a little bit. I'm going to change back to all green here. The numerator is just going to be f of x plus h minus f of x all over. And what happens here? You get x plus h minus x. You end up with just h. This is the difference quotient. So the difference quotient is a generalized form of the slope, right? The slope of the secant line. And the reason that's important is because it tells us what the average rate of change is.